Up until now, all the physics that we've developed with energy, momentum, forces, and motion has been in one dimension. And now we're going to talk about what happens in two dimensions. And a good way to summarize all this is that two-dimensional vectors can be broken into individual components, right angles to each other. And we're going to develop this without trigonometry at first. So for 1 week, we're just going to look at pictures and see how the components change. So we can first develop a good conceptual understanding, and then we can add trig later. We've already seen some of this. For instance, the boat is crossing the river at 3 meters per second. Let's call this the y direction. We could say the velocity of the boat is equal to 3 meters per second in the y direction, and that's a vector. However, the river is moving along at 4 meters per second, and we could say this is the x direction. So the boat, while it's moving at 3 meters per second in the y direction, it's also moving at 4 meters per second in the x direction. And so what is its resultant? The word is resultant velocity. When you add two vectors, the sum is the resultant vector. As we know, the boat would move in the y direction and it would move in the x direction as well, and we add vectors like this. No, we add them nose to tail. And so the resultant velocity of the boat would be in this direction, and we could write that 3 meters per second in the y direction plus 4 meters per second in the x direction. Now you could also express this in polar coordinates. That is, this is a 3, 4, 5 right triangle, so I know that the absolute value of its velocity is 5 meters per second in that direction. And that could be as simple as me saying the velocity of the boat is equal to 5 meters per second in this direction. And so what happens if the boat speeds up? Well, we know what's going to happen then is this component will get bigger. This component won't change. And so the resultant velocity will now be here. And so the faster the boat goes, the larger this angle becomes, because the y component gets bigger while the x component stays the same. Conversely, if the speed of the river got very fast in one area, we would see this velocity get very big and this angle would get much smaller because this component of velocity would be much larger. So now we're going to explore the 4 different lenses in 2 dimensions. And so what does this mean? We'll explore how momentum is conserved. The total change in momentum of a system is 0 unless there's an external force. And then that change in momentum is due to that external impulse. That the external work you put into a system is its change in energy. And that is the vector dot product of force times the displacement. That given a whole bunch of different forces, the acceleration of a body times its mass is equal to the vector sum of all of those forces, which can be in different directions. And lastly, for motion, we want to identify which are the independent directions. We're going to start with these two here.